So, welcome back. We are in section 7.3, dealing with Pythagorean theorem trig identities. So first remember Pythagorean's theorem. A squared plus b squared equals c squared, right? Okay. But when we're on the circle, a, b's, and c's are gone, and we have x and y, and now the hypotenuse is the radius, remember? So it's no longer a squared plus b squared equals c squared. It's x squared plus y squared equals r squared. Still Pythagorean's theorem, okay? The two legs of a triangle on a circle and then the radius of the circle. Now, here's the deal. You know, what you do to one side, you do to the other side to keep things balanced, correct? So I'm going to decide, and this sounds weird to you, but watch what happens. I'm going to decide to divide both sides by r squared. Y'all with me? When I do that, I end up with x squared over r squared plus y squared over r squared equals 1. Yes? Now, can't I rewrite x squared over r squared as x over r the whole fraction squared? Isn't that the same thing? Isn't that equivalent? Okay, so if you agree, then I can do the same thing over here and say y over r, the whole thing squared, equals 1, right? Now, I need you to think of your trig identities. We made that table back in chapter 6. X over r, think of your circle. X, does it refer to the cosine function or the sine function? That's right, cosine. So x over r is equivalent to the cosine of theta, which means I can replace x over r with the cosine of theta, and it's squared. Now, I can put parentheses around this and square it, but the typical way they write it is cosine squared theta, just like that. Y over r. The y refers to sine, doesn't it? So this would be sine squared of theta equaling 1. This is actually one of the Pythagorean trig identities, and it is the one we use most often. There are two more Pythagorean trig identities, so check this out. If I take Pythagorean's theorem again, now in this case, I decide to divide everything by x squared. That will leave me 1 plus y over x, the whole thing squared, equaling r over x, the whole thing squared. Now, think to your trig identities again. This is still a 1. Y over x, isn't that tangent? So 1 plus tangent squared of theta equaling r over x. Well, from over here, we know x over r is cosine. So I need the reciprocal of cosine, which would be secant. So here's the second Pythagorean trig identity. This one's used second most often, okay? This one's used most often. You get extremely familiar with this. This one is used second most often. And if you forget it, you can clearly derive it. It's very easy. And there's one more. I bet you can guess what we're going to divide by next. And if you can't, stay tuned. Okay, I'm back. Did you figure out what we're going to divide by next? Cool. So let's divide everything by y squared. I am going to get x over y, whole thing squared, plus 1 equals r over y, the whole thing squared. Now, x over y, that's cotangent, isn't it? So I'm dealing with the cotangent squared of theta plus 1 equaling r over y, That's the reciprocal of sine, isn't it? Which means this is cosecant squared of theta. This is the third Pythagorean trig identity, and it is used third most often. So if you forget the second one and this third one, it's clearly easy to figure it out. Divide by x squared or y squared to get these last two Pythagorean trig identities. How we doing? We okay? All right, now. I want to do some simplifying. And I want the answer written in terms of sine and cosine. So, first problem that we are going to simplify is us taking the cotangent of theta and multiplying it by the secant of theta. So here's the thing. Cotangent of theta. Isn't cotangent x over y? Okay. And when I'm on the unit circle, r equals 1, doesn't it? So, if I'm talking x over y, doesn't x refer to cosine and y refer to sine? When I'm on the unit circle, when r equals 1. So over here, couldn't I replace the cotangent of theta with cosine of theta over sine of theta? And secant. What's secant the reciprocal of? I hope you said cosine. So couldn't I rewrite this as 1 over cosine of theta? I'm just multiplying a couple of fractions now, aren't I? No big deal to multiply fractions. We try to cancel whenever possible. So couldn't I cancel the cosine of thetas because aren't they the same? And don't I just end up with 1 over sine of theta? Now the directions said leave it in terms of sine and cosine. So if you write this as cosecant, you're wrong. I'll take points off. Don't do that. You want full credit, you leave it as 1 over sine of theta. Are we cool? Good. Hang in there. Okay, I'm back. Here's problem number 2 that we need to simplify. Now here's what you need to understand. I know this involves a lot of trig functions, but aren't we just adding fractions? And to add fractions, don't we just need a common denominator? So that's all I'm going to do right now is I'm going to get myself a common denominator. And since one denominator is cosine and the other one is sine, then this denominator is going to get multiplied by sine of theta, which means the numerator also gets multiplied by sine of theta. Agreed? And I'm going to multiply this denominator by cosine of theta, which means this numerator gets multiplied by cosine of theta. Yes? All right, so check out what's happening now. I get sine squared of theta minus cosine theta times sine theta on the first numerator. Cool? Since the denominators are going to be the same, I'm going to make this one big fraction. Plus, now let's distribute. I get cosine squared of theta plus cosine theta sine theta. And the whole thing will be over cosine theta times the sine of theta. Are we okay with this? Okay, so do you see something that we can do here? Do you see something that's going to happen here? I hope you do, because what I'm noticing is that I have a negative cosine theta times sine theta and a positive cosine theta sine theta. So these two are going to cancel themselves out, is what I'm noticing. Which leaves me sine squared of theta plus the cosine squared of theta over this denominator. Now clearly I can't add sine squared theta and cosine squared theta because they're not the same. But flip your brain to trig for a moment, because all we've done here so far is algebra. So flip it to trig for a moment. And if you look back in this video, or hopefully you took some notes, you will notice that we have a Pythagorean trig identity that says if I take sine squared of theta plus cosine squared of the exact same theta, what does it equal? I hope you said it. It equals 1, which means the numerator will become a 1. The denominator, I'm still taking cosine theta times sine theta, and I don't know what to do with those, so I'm just going to leave them alone. This right here is a Pythagorean trig identity. This was cosine squared theta plus sine squared theta equaling 1. So I made a substitution. Out went sine squared plus cosine squared, in went the 1. They wanted me to leave the answers in terms of sine and cosine. There's nothing I can do to simplify this. I don't know what these guys are, so I can't multiply them together. So we're done. Cool? I'll be right back. Okay, look at the directions now. They want me to verify. They want me to prove that the left and the right side are both the same. Now, a couple of rules when you are verifying. First, you can only work one side at a time. Second, you can't move things from one side to the other. Not allowed. Which means I can't add something to the left and the right, or multiply something to the left and the right. So understand that. When you pick a side, that's the side you work with, and you're trying to legitimately make that side look like the other side. And sometimes people ask me, well, which side do I work with? I work with the side that has the most stuff on it. So in this case, that's going to be the left side. So I'm going to work with the left side only. And I'm taking a look at it, and I'm noticing that I'm trying to figure out if sine times secant is going to give me tangent. Now, me personally, I like to always put things in terms of sine and cosine. That helps me out a great deal because those are our basic trig functions. So sine is already good to go, but secant's not. So the sine of theta is going to stay the sine of theta. Secant, I remember, is the reciprocal of cosine. So I'm going to write 1 over cosine of theta. And this is supposed to equal tangent of theta. Now, these are fractions. And so I can multiply them together. And when I multiply them together, I get the sine of theta over the cosine of theta. And that's supposed to equal the tangent of theta, right? Well, sine over cosine, isn't that tangent of theta? So hey, the tangent of theta equals tangent of theta. Check, we're good to go. We verified that the left and the right side are exactly the same. By the way, you need to carry it out to this last line if you want full credit. So FYI on that one. Okay, got another one that we're going to verify. Okay, so here's the second problem they want us to verify. I don't know about you, but I'm working with the left side because it's got a lot of stuff on it, and I am going to prove that the left side equals the right side. Now, there's like 2 or 3 different ways that you can start this. It just depends on what you see first. So, if you are thinking of starting this a different way than I am, don't worry about it. As long as it's legit, go for it. So here's what I'm seeing. I'm seeing that I can rewrite tangent and cotangent. I'm remembering that tangent is the sine of theta over the cosine of theta, and that cotangent is the reciprocal of that. But I still have to remember to multiply by cosine of theta, and I'm proving that it equals this thing over here. Now, I can distribute into the parentheses, no problem, right? So if I take this first fraction and multiply by cosine, don't the cosines cancel? That'll leave me just sine of theta. If I take fraction number 2 and multiply by cosine, I'll get the cosine squared of theta over sine theta, don't I? And it's supposed to equal the cosecant of theta. Got it. Now, remember, a lot of this is algebra. This part I use trig on. I get that. But a lot of this is all algebra based. And I'm noticing that I'm basically adding 2 fractions because I can rewrite this over 1. Yes? So, to add the fractions, I need a common denominator. Common denominator would be sine. So I'm going to multiply the numerator and denominator of this first fraction by the sine of theta, which means I'll end up with the sine squared of theta plus the cosine squared of theta over sine of theta. I'm supposed to show that it still equals this thing over here. Well, in one of those last problems, we remembered that sine squared of theta plus cosine squared of theta equals, that's right, equals 1 because the Pythagorean trig identity. So I have 1 over the sine of theta. And that's supposed to equal the cosine, cosecant of theta. And yes, this is true. 1 over sine of theta is cosecant of theta, and it equals cosecant of theta. And check! I wrote the last line. I proved it. Full credit. Yay! Cool. Have fun with the rest of the verifying.